Okay, in our next example, we're going to do something different. So till now, they gave us the equation or the function, and they asked us to draw it. In this case, they gave us, let's say they're going to give us two coordinates, and then they say we have to get the function expression or write the formula for the function. Obviously, if you wanted to draw this is very simple. You just go and you find a, where a is 2 and 2, so that would be there. And then where b is 4 and 2, which would be, 4 and 6, which would be there, and you'll just draw a line. But we're going to do it kind of the other way around without the graph. And there's some important tips and tricks we have to understand. So the first thing we start off with is our standard form, and that would be y is equal to mx plus c. So y and x, these are the input-output values, so they correlate to the coordinates. So for example, if I had the formula and I put in x is 4 in that place, then doing all the magic, etc., and the function would work out. I would get y as my answer, as 6, or if I put 2 in there, I would get 2 out. Okay, so that's input-output values. But now I don't have the m value and I don't have the c value, so I don't know what they are, and that's kind of what they want us to figure out. So for this, there's a little formula that we have to know for the gradient. So you know the gradient is the change over y over the change over x. So the change would just be the difference between two things, the start or the finish. So we can write a formula here as like the change over y would be y2 minus y1. Now what is y1, y2? It's just the y coordinate of the second coordinate and the y coordinate of the first coordinate over x2 minus x1. So you might ask, but why is it now, why am I doing negative? Why is it not 1 minus 2? Why is it 2 minus 1? So it's just for the difference. So if I wanted to find the difference between like 10 and 5, it would be easier, and I'd get a positive value. If I said 10 minus 5, that would give me a positive value. So it's more just about positives. It doesn't really matter which way you turn them. If you turn them the other way, you should just be careful about, you know, the signs of the, you know, the values. But let's just go take a look. So that would be our first order of business. Now my tip would be is choose which one of these would be the first and the second coordinate. So I'm just going to choose this. Again, as long as this is the first one or the second one, just keep with whatever you choose. So I'm going to start with a as first. So I'm going to say this is my x1 and this is my y1 because this is my first coordinate. And I'm going to say this is my x2 and my y2 coordinate. Again, I could switch them around. I can make this x1 and that y1 and this x2 and y2. It makes no difference as long as I just stay consistent. So for this formula, I'm just going to fill in. So y2 is that one, which is 6. It's a positive 6, and I can, obviously that would be better to put it in brackets because it's substitution. I put the minus there, and the y1 is the 2. And the x2 in this case is the 4. Didn't have to put brackets because everything's positive values, but it's just a good way of writing it. And for our next one, we have our minus, and x1 in this case would be 2. So this is 6 minus 2, nothing weird there, and 4 minus 2. So 6 minus 2 is 4, 4 minus 2 is 2. So our gradient is going to be 2. So m is 2. So if I have my standard formula, which I'll just write here, y is equal to, I've just figured out that m is 2, 2x plus c. So that's step 1, is trying to find the gradient, which we did. Now we have to find the c value, or the y-intercept. Now, conveniently, they gave me a coordinate, and this is an x value, and that's a y value, and I know if I put x into this, I would get y out of this. So this is an equation with 3 variables, but I can put in 2 variables, x in x's place and y in y's place, and then there would only be one unknown value. And then I can work that out with like algebraic magic, okay? So it would work with either one. So I can put in a into my function, and y is 2 is equal to 2 times x is also 2 plus c. So all I did is I took this coordinate and I took the x and y values and I put it in the x and y's place there. So now I have 2 is equal to 4 plus c. And if I take 4 off on both sides, then I have 2 minus 4 is c. So minus 2 is c, or c is minus 2. Okay. I'll prove that the other point would give the same answer. So if I were to put in b, 4 and 6. So y in this case would be 6 is equal to 2 times x in this case would be 4 plus c. So I would get 6 is equal to 8 plus c. So take 8 off both sides. So I would have negative 2 is c. So with both cases, I have negative 2 as my c-intercept. So if I wanted to write this in the equation, it would be y is equal to 2x minus 2. Okay, so graphically, yes, we can check if that's true. So if I make the point A 2, 2, 2 and 2, that would be there. And if I take B 4 and 6, 4 and 6, and I go there, then we can draw the line. Draw the line, and there's two things we can check now. We can check whether our gradient was correct, and we can check whether our y-intercept was correct. So the easiest to check first is the y-intercept, so negative 2 is negative 2 right there, so we got that right. And then for the gradient we got as 2. So if I had to rewrite that as a fraction, or 4 over 2, that would be 2 over 1. So the change in y over the change in x would be 2 rise, 1 run. So if I started here, or let's say I start here, and I jumped 2 up and run 1, I get to the same place, everywhere on that line. So we can do another example quickly. Oh wait, let's do one in the next video. Yeah.